Okay, I guess I had a computer issue because it was really slow until something was running finished. That's why the program was slow and I couldn't make my 3D maps. Once something was finished and I would be that my program just ran fast. Okay, solo map. Let me open it up for you, and I created 2 maps. It didn't took me that much time, and it was fun to make the map, and it was very useful, some tool, and I never run it before, and for the visualize. Okay, let me just show you. It's in my Dropbox. Okay. The first map that I have is this is the San Francisco, and the second one is, let me bring up the second one. Okay, solo map. So that's the 2. Okay, it's really pretty, and we can calculate it, and I think I did this one. It just took a long time to see those dots to render it. It wasn't, there was nothing wrong there. There was nothing wrong there. And I could add this classification here. I guess there wasn't a classification because the dots, just the value here, the same here, and even with this. And the previous, this one, I changed it. You just have to wait it for a long time for the dots to render. And this one I changed it into the dots. So even now it's gonna take a long time because I had the array imagery. And for some reason I think the computer is still slow a little bit. Once you have a slow computer, it's really difficult to work on it. But I think right now it's fine. Computer is back on. I shouldn't have any issue, and you can see very easy to move around. And I don't want to touch that data. And it's pretty too. Okay. And this is the solo map. And the last chapter is about forest vegetation height. We still work on LiDAR data. So the LiDAR has variety by applications, including the management of natural resources. So by differentiating between different rate terms, LiDAR data can be used to establish the canopy height of trees in a forest and providing critical information to help steward these critical resources. First, we're going to create DEM, Digital Elevation Model, and DSM, Digital Surface Model, returns from an LIS dataset, and we will use the raster calculator to subtract DEM from DSM to calculate canopy height. And we will identify and investigate problem areas in the LiDAR and produce a classified map of canopy vegetation. What we're going to need is we have to do the publisher and the administrator role. So now I'm gonna take this too so we can see at the same time. Okay, the map, I can make it nicer. But as for this too, it's fine. Cool, it's really nice. I think for this, the background I can make a little darker, maybe 50% gray. Yeah, I'm gonna do 50% gray, and I'm gonna change it real quick. Property, symbol, property. Okay, I'm going to change a little bit color, and I'm gonna change property 70%. We'll do 50%. Click apply. Maybe 30%. Let me see, 30%. Click OK. Click apply. Close it out. Rectangle, I'm gonna make it down, move it down, there. Alright, the same here, move it down. Property, go to symbol, 30%, 30, click OK, click apply. Okay. There. Go to symbol, and I will do 30%. Okay. Scale bar, and where's my legend? Move it up. There. Okay. Now this looks a lot nicer. Save it. And go to share. The scale bar, yeah, could be a little weird. Let's do properties. And I'm not gonna do, the scale bar. Yeah. I'm gonna go to format. And the fill, gonna do this. There. So, cool. Alright. And gonna go to share and save again. Where is my San Francisco map? San Francisco map. Solar. Okay. There. Yes, replace it. Cool. And we have the title, and title a little transparent. Looks a lot nicer, and we have the legend and the scale bar. Okay. Okay, now we will start a new one. Yeah, save it. Okay, Arc map. Okay, ArcGIS Pro. We're going to start a scenario. The land managers can learn a great deal about the history of a forested site based on the amount, distribution, and height of the vegetative cover, and the impact of wildfire and disease, the growth of young trees, and the presence of habitat features favored by certain wildlife species are all important types of information that can be derived from LiDAR. Most of this information is currently collected through time-intensive ground surveys, often in remote locations. Increased efficiencies in data collection will be welcomed by land management, species, and organizations. So the Nature Conservancy's Virginia chapters want to use LiDAR to estimate the extent of various successional stages using vegetation height as a surrogate for age. And this knowledge will allow the land managers to better understand what restoration and management techniques may be necessary to maintain a diversity of forest communities and species. LiDAR provides the opportunity to characterize different strata in ways previously not possible for satellite imagery. And canopy height might be determined by subtracting the bare Earth surface from the first return surface. So the first return surface, DSM. The data, there is a data they provided online that's really cool. And deliverable deliverable that we will do is the following. Deliverables are recommended: base map showing location of an LAS data set, and a layout showing a DEM and a DSM. And the height of the forest. So now we're going to, I already have the data, and I'm going to save everything, and I'm going to extract the package. If something it's not working, then I think better I just extract the data and into a file, and then I copy it in my folder. So I think that's a lot safer way to do. Okay, I'm gonna do that, and I will show you. The same way, we go to blank. For blank, we will navigate to our folder. From our folder, we will have to go of course, desktop, and here okay, and making spatial direction, click OK. And the name, I will just say let's see, okay, forest, VA forest, click OK, and just wait for it until, okay. Okay, and then, no, and then go to map. Okay, so now I have the map, and then I'm going to map. Okay, I'm gonna extract the data first. Go to downloads and VA forest. That's the last folder. Yeah. Okay, this 2 folder we have to Pennsylvania as well. Okay, now I'm going to 7-zip and extract file. Once extract file, then I will copy it to, while extracting file, right click on it, add folder connection, and go to my folder. Okay, making spatial data decision, and then I'm gonna go downloads and right click on it, and I'm going to cut. After cutting it, go to desktop and go to my folder. Okay, paste it here. There. I'm going to refresh. So I'm going to look for the data, which is right here. I would say never use extract package because I really don't like it. It's better you extract it and copy the data there. So now I have the data, right click on it and add the layers to current map. It could be different in your situation because depends on what version you use and what Windows version you are using. If you are using Windows 7, it could be different. And now I'm going to look the data. This is the LiDAR data, and they already added here. Okay. I add it to current map. So when we add the data to the map, ArcGIS Pro creates a layer from each data source and the layer reference the actual source data and can contain many different display properties. For example, we can change the colors of layers and how they are symbolized, the layer name and label. So now we can see the data display in the contents pane and on the map view. Okay, now I'm not gonna play around, so we just look at the spatial reference. This book really like the spatial reference. Some book really like. Oh, go to the book. Let me see if I have to add that layer. Okay, no, I don't think I have to. Right-click layers. I don't have to add the data. So here I'm gonna explain a little bit in the user data. Okay. And the photo connection will remain this project for the duration. I already add the connection, and inside the data folder we will see a P folder that contains this layer, and this is the LiDAR data, and we will see the FGDC, USGS, NRCS, Virginia, LAS.xml, and this is metadata for the LAS file. Okay, and now I'm going to check the coordinate system first. Okay, source. Okay, spatial reference. That Lambert conic. Oh shoot. Lambert conic. Oh, I don't know where did I get this Lambert conic. Okay. All right. Alright, so now I'm gonna go to analysis, and then now okay, the same with this. Do I do extent? Okay, yeah, I do extent. Click OK. I should have everything. Okay, and now create a process summary. For the process summary, a process summary lists the steps we use to do the analysis, and the summary is important because it will allow us or others to reproduce the work, and we okay. And we suggest using a simple text document for the process summary and keep adding to the summary as we do the work to avoid forgetting any steps. So the next list shows an example of the first few entries in a process summary. Extract the project package, produce a map of George Washington National Forest, and create our ASD dataset and examine the LiDAR data. The analysis, once we have obtained the data and set environments. Okay, now once we obtain the once we have obtained the data and set the environments, we are ready to begin the analysis, and we're going to complete the data display. Okay, for here, we have we're going to identify the different heights of the tree canopy. So we have been asked to identify. Okay, we will display the needs to address the problem. Okay, now deliverable 1 and base map showing location of LAS data set. We will create a base map. Deliverable, we will do base map showing location of an LAS data set. We will create a base map. In the contents pane, we will right click the square under counties and extend, we will do hollow. Counties, okay. No color. Okay, then do I do this? Hollow? Okay. And we will right click the square. This is George Washington National Forest and select a dark green or represent the forest. Dark green, okay. And on the map tab, we will click base map and change the to imagery with labels. Map, imagery with labels, okay. And what is the town's location relative to the G, W, and F? The town. There are so many towns. And oh, to the east, to the south, to the east. This Lexington, and to the south, there are so many towns and towns. If we count those, okay. And we will create. Now we are ready to create the LAS dataset. On the Analysis tab, we will click Tools and search for Create LAS dataset. Okay, Tools. Okay. tools and we will search on the analysis tab. Click tools and search for create LAS tools. Okay. LAS data set. Oh, it's create. Okay, now we double click the tool and we create LAS dataset. And I'm gonna do is double click this tool and input file. I'm going to navigate to the file. So desktop and book data, making spatial. Okay, and Virginia Forest data, common data, user data. Okay. LIS and System 39. Oh, it's a little different, but it's okay. Okay, and I have this an output data set. I think I'll just use default. That's fine. And output coordinate system. Lambert, okay. No LASD file, compute statistic and store relative path. Click run. There. And we zoom to, I'm gonna drag it on top. Where did it go? Data percent 0. I'm going to go to symbology, appearance, symbology. Okay, I'm going to put all points. We cannot see anything because I think the reason is that is really weird. Go to analysis, environments. Okay, for here, I'm not gonna do this anymore. I'm going to go to desktop and click here. Right. Virginia. Where is Virginia Forest? Alright. Virginia Forest, okay. Oh, no, not this one. Okay. Forest, not this one. Okay, layers. Not counties. I know it's this one. and then click OK again. I'm going to run the tool again. Input, click Open, check, click Run. Data percentage. I think something wrong with this data. Nothing shows up. Okay, let me see if I go to Appearance and the drawer using elevation and minimize it. Close it out. Nothing shows up because here it says data showing percentage. Nothing shows up. I think there could be another reason. Let me double check the file. Okay. I'm going to find the data. Okay. Hopefully I have it. Okay. Let's see. Alright. Okay. Let's see. This layer gave me trouble, but it's okay. We will figure it out. Let's see. Okay. I'm going to search this layer, and I might have to download it. 16 and underscore 3903 and underscore 10 dot LAS. 16. Oh, this is not. Is it slash? Oh, it's dot. It's dot. Let's see. Nothing. Okay, I'm going to go to the website and see what's going on. I need to find the data. HTTP, hopefully vgene.maps.arcgis.com/home /home and /item.html and question mark ID. This is gonna be fun. ID equals 1E 96B and then 36B, letter B, and then 454 A1 2 and then A69 A3 AD 0 BC 1473 CE. Click enter. Let's see what's there. VGMaps.com home item HTML. Oh, this is ID. Okay. Not OD, ID. Click enter. Okay, I still need to double check. One 1E96. Do I have a 4? Yeah, I do have a 4 here. Okay, letter 4. 4 BE 36B. Oh. Yep, 454 A 12A 69 A 3AD 0 BC 17. Okay. This data is really crazy. Can I do ground data? If the data is 0%, something wrong with it. Where is the data? There's nothing imagery here. Okay. I don't need to turn on this. How come the data percentage is 0? Okay, this one already have a 0% of data. I think this one has something wrong with it. Okay, I'm going to open a new map. Okay, and then go to Insert, New Map. I'm going to extract the other one and see if we have 0 data. If I have a 0 data, I couldn't do anything. Yeah, I do have a layer, and when they open it up, it's a different file. I think it should be 39. Okay. I'm going to extract package as well. Go back to this one. I'm going to go to Analysis, Extract Package, and see. Extract package. Extract package and input. Going to go to Downloads, Virginia. Okay, click Open. An output folder, and I have to navigate. Okay, there. It's making spatial reference. Click Run. And then when it's done running, why not I have to do this again? Alright, I'm in here. I'm going to open the other one. Go to Downloads. Okay, right here. I go to Downloads, and I'm going to go to PA, right click, and then Extract File. Extract File. Where is Extract File? Okay, 7-zip, and go to Extract File, and then click OK. Okay, and then I'm gonna cut it. Go to Cut and paste it here. There. So now this one is done extracting. Let me go to P13. Virginia. Okay, common data, user data. That's not this one. So this is Virginia. Okay. Common data. User data. Then okay, that's this one. Let me see if this one has some data. Ew. This one has no data. Data percentage is 0. Let me add it here. Okay. So now I'm going to okay. I'm going to specify this again. I think this is fine. It has something to do. Let me browse it again and go to desktop. No, not this one. Okay. I'm going to load it again. So there. and Virginia forest, and P13 Virginia layers, and I need this, and click OK once I have it. Okay, once I have it, go to analysis. I'm going to create this data set and load it again. Desktop, this, and here, and then Virginia forest data. Okay. Open, run it again, check, click run. There, oh my god. I think just something wrong. Analysis, I'm going to, it doesn't matter what the procedure as long as I have it. Okay. Why there is a thingy here? And I'm going to bring my layer back, okay? I'm not sure what's wrong there, so I took her a map. Okay. Going to put this on top. Oh, I think the red thing is just rendering. It shouldn't have that there. Okay, now this is the LiDAR data, and let's see. This I'm gonna just put it no color, and this I put it on top. Okay. And I'm going to put it down there. This one, the percentage is 0, and then it showed up. I'm going to change it. Click OK, that's fine. I'm going to change it into darker green. I have to see what's going on there. It's just really weird that it's just this spot has the LiDAR data. I think maybe just one spot. And I zoom here, I double click the value legend and move the symbol scale slide towards minimum. And going to go click and go to appearance. I'm gonna change it into minimum and see what's going on. Yeah, more dots. Okay, minimum. Then I can see more dots. Cool. In what range of mountain is this located? Elevation. Then I guess that's the range. And it just the units we have to log, I think it should be foot. And now data percentage change to 4.8. And let's see. Click OK. Let me go back to this one. Oh, what happened here? Oh, that's the James Madison University. Oh, I think it's not something wrong. It's just I have to zoom in to layer. Oh, this one shows up too. It's just too tiny. Oh my god, it's just too tiny that I didn't zoom in to see. Okay. Both are correct. Oh, I didn't know it was just that tiny spot. That's good to know, because usually our study area is just so huge, okay? And now, in what range? We should understand the basic details of the data set before we begin any study, and the metadata was downloaded, okay? From the Villain and Mary Center for Geospatial Analysis. Whelan and Mary Center for Geospatial Analysis, along with the LAS data, and can be accessed in common data, user data, as the FGDC, USGS, NRCS, and VA. SML. However, there are easier ways to examine the metadata. And then we find point spacing. Okay, now I'm going to right click on this layer and go to properties. Once I'm in property, now I'm going to explore something. We will look at the coordinate system source and go to reference. Coordinate system, and we will have a vertical units right here, US food, and classification code, cache elevation, it should be right here, LAS filter, and point spacing, the same one. I will do Python. Let's bring Python window. It should be in view. I'm gonna go to Python. I'm going to dock this there. Okay. For Python code, I wish I have a really good memory so I don't have to look each time. Let's see, the Python window for the spacing. Okay. Let's see, when do we use spacing? Python code. Line down. Okay, we started from chapter 7 and the Python code. Spacing. Okay, I have to import ArcPy first. Okay, import ArcPy. Import ArcPy, and then ArcPy dot describe, and I have to put the name, copy, paste. Alright, once I have the name, dot point spacing, capitalize S spacing. Okay, it's 1.5 something 1.5. Oh, they have it here for me. 3.3. The only data that we cannot find is the property tab, is the point spacing. Here it mentioned again, point spacing is an indication of how close the data points are to each other, and point spacing determines the resolution of derived gridded products, and the point spacing used in calculations is an average because point spacing is not consistent within the data set. And for example, tiles that have a large bodies of water would have a large average point spacing because the large empty space presented by the water. So, and we remember, I didn't remember it. I just went back to look, and here actually they provided for us. And the DSM I created many times, and now I'm working with those data again. So it's very interesting that we work on this, and we will put everything together, and including the study area. And I have to lay out nicely for the map. And once we generate the map, then we will have a D and an SD. Well, it's a challenge to lay it out, and I don't think I can do everything today, but I will get back to you for that point. And now we will do deliverable 2. I'm going to save everything. Then a layout showing a DEM and a DSM and the height of the forest. And raster data is one of the most common GIS data types, and a wide range of analysis can be done with raster or gridded data. For the vegetation surface analysis, we will convert the LIS data set into DEM and SDN rasters. And remember that LiDAR is elevation data that we can classify into various surfaces by filtering the data. And a DEM is a bare earth model. Okay, and with a ground classification that shows points that are classified as ground compared to DSM that shows the first return data from all classification codes, and we can access this data on the appearance by clicking the filter Show See the menu, and we will create a DEM. And for this part of the analysis, we must make a new map. Okay, I already have a new map, and then we click map and show that, rename the map. Click map to show the current map, okay, and click that map, and I'm going to rename. I have so many maps, so which is fine. On my map 1, I'm going to rename it GWNF, George Washington National Forest, and we're now going to create a map showing the DEM. Okay, then I'm right click and copy this and paste the map and rename the copy DEM. I think I have it. Okay. So this one, I'm going to name it DEM. Okay. And after renaming the map, we double click the map and we will see the two maps that we can toggle between, and we can click multiple views together and dock them side by side, and we can also link multiple map views together within the same project. And on the View tab in the link group, we can click Link Views and select the models, Mode Center and Mode, and move the DEM map and the GWM map. So now we can toggle between each map, and we will ensure that DEM map is highlighted, and click this and zoom to layer. And I'm going to change the DEM. Now we are working on this, and I'm going to, oh, that one is already changed. Go back to DEM. Once I have a DEM, I'm going to change the appearance of this data to 2, 5, 1, 2, 3, 4, 5, and move the density to maximum. Now computer is faster and it's render fast. Last time I don't know what's going on with the computer. It's just so slow each time I move. It has to do with the computer. When I rebooted it, it doesn't work. I think something must be running. And on the appearance tab, I will choose ground. Okay, appearance. Okay, LS point, I change it into ground. Okay, now I have the ground, and I need to remove some of the data. I think I did the wrong one. Okay, I'm going to remove this, and then I'm going to I have so many. Remove, and then remove. Okay, this one I'm going to first symbology, not symbology. This one I'm going to change it to ground. Okay, now this is ground. I'm going to 25, 1, 2, 3, 4, 5, and change it into maximum. There. Okay. And then I will convert it. Okay, once I have everything, 25, 1, 2, 3, 4, 5. Okay, hit enter. There. Okay. I need to reach the maximum. Okay. And double check ground. Okay, now go to analysis and go to tools, and we'll have to search the tool. This tool I'm going to use is LAS data set to raster. Okay, LAS data set to raster. Once I have it, and then I'm going to input, it will be this one. Okay, and output, that's fine. Output, I just name it DEM. Okay, elevation binding, this one we will be maximum, right? Maximum, natural neighbor, and floating point, cell size 10 and 1, and click run. Okay, Z factor is 1. Click run. Okay, so that's the layer DN, output raster, value field DN, and then elevation, yes, and then interpolation type, we have a binding, and this should be maximum. I have to run it again. DMM max. Okay, natural. It will be natural neighbor, floating point, cell size. Okay, it's 10.1 and click run. Okay, it's running. It should be added to another one. So this is the maximum, this is the minimum. We can see there are some difference, and we will do symbology. Okay, right click on it, and I'm gonna go to symbology. For symbology, I will just do color scheme, and show name, show all. I will do elevation number 1 and expand the DM. And what is the unit for DM, and what are the lowest and highest elevation represented here? It's right here. And what is the unit for? Okay, let's look at its property and source and raster information 10 to 10. The cell size, okay, and we will change the base map into imagery with labels and turn off counties and turn this off. Click OK first. Turn this off. Turn this off. Turn this off. This is our DEM. And write a brief spatial description of the LIS data frame. I'm not gonna do that. I have to run another one, and we can calculate vegetation height. There is a lot more to do once we calculating the height, and we will do, I think we will do reclassification once we have a reclassification, and I will have a 5 maps, and once I have a 5 maps, then I will put them all together. 1, 2, 3, 4. Yeah, I have the height, I have the DEM, and have the DSM. I think I will run one more, create a DSM, and we will copy and paste. Rename this in the catalog pane. We will copy DM and catalog pane. Okay, so max copy and then paste. Oh no, I don't need to paste special. I can just do paste, copy and paste. Okay, then alright, then I'm gonna DSM. Okay, this is minimum. I'm gonna rename it. This is the minimum. There. I have a DSM. Once I have a DSM, and in the view tab, we will click link view. I'm not gonna do that. And on the appearance, on the filter, appearance, we choose first return. Oh no, not this one. It's really confusing. Okay, I'm going to copy this and paste. Okay, this one I will say it's DSM. Okay, once I have a DSM and click this, alright, I don't need to link now, and go to filter, go to appearance, and filter points. It will be first return. Choose the first return. Once I have first return on the analysis tab, we will do LAS to raster. Then once I have it, and this input and output, okay, DSM. Okay, DSM. Okay, binding, maximum. Alright, and this time is natural neighbor, floating cell size 10 and 1. Okay, the same way, this is DFM. DSM. Okay, once I have DSM, okay, then I'm going to right click on it and then go to symbology, go to elevation 1. Okay, there, and now I have it. So we can just, okay, I can just, there are differences, see? Okay, and what is the unit for this, and what is the highest, lowest? There are difference, yeah. I'm going to go to property and raster information, yeah, 10 by 10 cell size. And calculating vegetation height, we will continue back, and then I will lay those maps and make it nicely. Then we will be done, and we will work for the Pennsylvania one the same way, and basically the same method in the Pennsylvania Forest LiDAR, and I will put the height DSM. Okay, I will see you next time. Alright, save everything first, and I will close everything out. Raster layer, I think I will put everything here. Okay, the data, it just takes some time, and it's just so tiny there. Okay, see you next time.